Welcome. This video is on a review of arrays in C++. Our class is starting off with a review of some C++ programming topics, and the first thing is arrays. As you may know, an array is an aggregate data type. That means it's a data type that holds more than one thing that are connected together or aggregated. So an array stores multiple elements. Each element is one piece of information stored in that array. Later on, we're going to talk about an array as a formal data structure. We have a whole way of talking about data structures as abstract data types. We'll get to that. For now, we're talking about the conventional programming array. As I mentioned on the previous slide, an element is just one object stored in an array. Typically, an array has many elements. The base type of the array is the data type of one single element, and all of the elements in an array have to have the same data type. So if you have an array of ints, the base type is int, and every element in that array has to be an int. An array has a fixed size. That means that you create an array with a certain size, like 100 or 1,000, and the array is stuck with that size for its lifetime. You cannot change the size of an array after you create it, and that creates some obstacles, and later in the class we'll see how to work around those obstacles. We sketch an array as a grid where every element is in a box and they're all connected together. So for example, an array that contains this series of integers 2, 7, 8, 2, 0, 1, 1, we would sketch like this, a grid. And so every one of these rectangles represents one element in the array, and the values are inside those rectangles. This is denoting the fact that an array is contiguous in memory. This is how the elements are actually laid out. They're all next to each other like this. So the first element is adjacent to the next element in memory. Their pointer addresses are very similar. We're going to go over two different syntax patterns for creating an array. One is what we call the C array. This is the legacy array syntax from the C programming language. As you may know, C++ was created by adding to the older C language. C had a way of declaring arrays, and the C array is that. The pattern for declaring an array of capital N elements of base type T is T and then the identifier you choose, and in square brackets N, the number of elements. For instance, if I want to make an array of 7 ints called digits to correspond to that sketch in the previous slide, here's the code that would work in both the C and C++ languages to declare that array. Every element of an array is uninitialized when the base type is like int that does not have a constructor. So if I were to sketch digits after this moment in the code, I wouldn't know what value is in every element of digits, so I would probably draw a question mark, meaning uninitialized. It's undefined what particular value is at each individual element of my digits array. And it's my job as the programmer to initialize those elements. We're also covering std array or standard array. This is an object-oriented array data type that was added in C++ 11. This is the name of the version of the C++ programming language created in 2011. And it's kind of a better array, at least for C++ programmers. It behaves like the other C++ data structures. The C++ language has standard vector, standard string, standard list, other data structures, and they have a particular interface with constructors, the concept of iterators, certain member functions like swap. The C array has none of those things, and that's confusing and inconsistent for C++ programmers. So standard array exists to make all of these data structures work the same way. You can create a standard array and have access to things like iterators and swap, so there's no discrepancy there. The syntax pattern to declare an array of capital N elements, that's the size, of data type T is standard array T, N. It's a template class, and you put the identifier there. It's a little tricky to remember which comes first, the T or the N. I have to look that up every time, honestly, but you kind of get used to it. So for example, if I wanted to make a digits array just like the previous slide, I would say standard array, base type is int, size is 7 digits, and there we go. It would create the same data structure. I want to focus a moment on what's going on here, which is that we have two different alternative implementations of the concept of an array. This is a theme that we will be revisiting in this data structures course, and it's a theme that shows up in other places in computer science as well. We have two different alternatives for an array, or two different ways you could create an array. There's the C array or legacy array, and it defines a certain interface for accessing individual elements. That's the subscript operator written with brackets and the way that indexes work. We're going to review that next, but you're probably familiar with it. And the interface for standard array is the same. All of these things still work in std array, the dereference operator and the indexing scheme. So they're kind of interchangeable. If the only way that you are using an array is with these operations, the subscript operator and indexes, then it kind of doesn't matter which one you create, C array and std array. And so that means they're directly comparable. We can say for a given situation, which one is better, C array or standard array. Us being scientists and this being a scientific enterprise, we use scientific reasoning to try to make that decision. We don't just guess or go by habit or something like that, but we look at evidence to see which one is better for the situation. And that's a theme we'll be doing all semester. When we get to list data structures, we'll see there are many alternative implementations. There's array, vector, singly linked list, doubly linked list, there's others. And when it comes time in software development to decide which one to use, we use science and reason to decide which one is most appropriate. Back to how we access individual elements, that's called the subscript operator. And for an array object A, the expression A square bracket I is the way that we look up one element in A that yields an L value for the element at index I. L value is a bit of C++ jargon. It means a object that can be read or written. It's a read or write value. Some expressions in C++ you can write to, some you can't. So L value, it's because it's L for left, it can appear on the left-hand side of an assignment. And the I part of this is an index, number I, and I has to be an unsigned integer or something that can be converted to an unsigned integer that's a valid index, meaning it has to be at least 0 and strictly less than capital N being the size of the array. So a bit of a weird convention, but it's one that we use consistently. It's another one of these things you kind of get used to. So for an example of usage, let's say I want to fill up an array. Here's this alternative implementations concept. On the left, we have a C array declaration, double points 100. That creates an array of 100 double floating point numbers. And I've got a for loop. I'm using the size t data type for I. Size t is the data type in C++ for a index, basically. So I goes from 0 up to but not including 100 because the indexing rule is start at 0, go up to but stay less than the size of 100. Increment I every time, points of I equals 100. This is the array subscript operator right here, and it's demonstrating this L value concept that this subscripting is allowed to appear on the left-hand side of my equal sign, my assignment operator. On the right-hand side is an alternative where I'm using C++ standard array. It has the same effect. Array, base type of double, size of 100, call it points. From then on, the code is identical. And this goes back to what I was saying. We have two different ways of implementing the same interface. So the C array and the standard array are interchangeable from the moment that they're created.